Hello everybody, welcome to Day 2, Section 9.2, Adding and Subtracting Rational Expressions. So today's goal is to determine the LCM of polynomials, or least common multiple, and then we will add and subtract rational expressions. So adding and subtracting fractions. Okay, so let's just go through some quick fraction review here. Okay, if we zoom in and we simplify. So what do you remember about simplifying fractions? When you're adding or subtracting, hopefully you remember that we must have common denominators. Once we have common denominators, we can combine the numerators and we keep the denominators the same. Okay, so if we take a look at part A, 9/16 plus 3/8. Hopefully you recognize the common denominator is going to be 16. So what we have to do is multiply this second fraction by 2 over 2. So we have to multiply 2 to the numerator and 2 to the denominator, because 2 over 2 is just like saying 1. We're not changing any value here. So we keep the 9/16 the same, and now it becomes plus 6/16. Now that the denominators are the same, they're both 16, we simply add the numerators and we keep the denominators. So 9 plus 16 is 15, and my denominator stays 16. Okay? So part B, really quickly, we're looking at 2/3 minus 5/7. Hopefully we recognize that those are not the same denominators, so we need to get them the same. And the common denominator this time will be 21. So I have to multiply this first fraction by 7 over 7, and the second one by 3 over 3. So what we get, 2 times 7 becomes 14 21sts. Minus 5 times 3 is 15 21sts. Now that the denominators are the same, we can go ahead and combine the numerators. So 14 minus 15 is -1 over 21. Okay? All right, I want you to finish C up on your own, get the common denominators, and combine your numerators. All right? So what we were doing with getting those common denominators was we were finding the least common multiple of the denominators. All right, so that's going to be key with this section. Okay, whenever we're adding and subtracting rational expressions, we need to determine the least common multiple. So the least common multiple, or you'll hear me refer it to the LCM, okay, is the smallest number or expression that all factors go into. Okay? So LCM, that's a key. Let's see what we're talking about and look at a few examples where we are going to determine the least common multiple between certain expressions. Okay, so in order to determine the LCM, kind of a rule of thumb is we are going to break up into prime factors. Okay, so if we take a look at A, 6 and 9, we want to figure out the least common multiple. Now, some of you guys might be able to look at numbers and determine the first number that they both go into evenly. Others, it might take some practice. So I'm going to just do a little side note, and I'm going to show my prime factors of 6, and I'll show the prime factors of 9, and then we can determine the LCM. So 6 can be broken up as 2 times 3. Okay? And 9 can be broken up as 3 times 3. Okay? So when we're determining the LCM, here's kind of the rule of thumb I follow, is our LCM. With my first number, in this case it's 6, I write down all of the factors that make it up. So we have 2 times 3. Then I move on to my second factor, or my second number, I should say, my second expression, 9, okay? And I only write down new factors, okay? I don't write down the repeats. So I take a look, okay, 3. Do I have a 3 already? Yes, we already have a 3 in the LCM. I move on to the next factor, another 3. Do I have a second 3 in my LCM? And the answer there is no. So I have to write down that 3, okay? So I only write down the new factors, okay? And now we just multiply through. So 2 times 3 times 3 is 18. So the LCM between 6 and 9 is 18, okay? So let's try that again with this part B here, okay? So we have 4a squared b, and we have 5ab cubed. So again, I break it down into the prime factors. So for 4a squared b, first I break up 4 is 2 times 2. A squared can be rewritten as a times a, and then we have a b. All right? 5ab cubed can be written up as, let me use a different color here. We've got 5 times a, and b cubed can be rewritten as b times b times b. Okay? So now when we're determining the LCM between these two expressions, I write down all of the factors from my first expression. Okay? So we have 2 times 2 times a times a times b. Okay? Then I go through my second expression and I only write down the new factors. Okay? So if we take a look, I've got a 5. Do we have a 5 in the LCM? No, we don't, so we write it down. So times 5. All right? Next factor is an a. Do I have one a already? Yes, we do. Next factor is a b. Do I have one b already? Yes, we do. Then we go on. We've got another b. Do we have another b in the LCM? No, so I have to write that down. And the same goes for this last b. I do not have a third b, so I need all of those accounted for. Now we just clean it up. So 2 times 2 times 5 gives us 20. A times a gives us a squared. B times b times b gives us b cubed. So the LCM between these two expressions is 20a squared b cubed. And just a little side note, if you take a look at our variables, a squared, do you see that anywhere in the expressions? Oh, there's a 4a squared. And we've got a b cubed. There's our b cubed. So the variable with the highest degree is going to be part of your LCM. Okay? This is all going to help us when we add and subtract on the next page. So let's just try one more and then we'll move on. Okay, let's look at part C. This time we've got polynomials. We've got trinomials actually. So when we are breaking up our two polynomials, a squared minus 3a minus 4 and a squared minus 9a plus 20. Well, we have to break it up into the prime factors. So we have to factor these polynomials. Okay, so factoring a squared minus 3a minus 4 Hopefully you recognize that that is going to be a minus 4 times a plus 1. And then factoring our second expression here, a squared minus 9a plus 20. Hopefully you recognize that that is a minus 4 times a minus 5. Okay, and now when figuring out the LCM, I go through my first expression and I write down every factor that's there. Okay, so we have an a minus 4 and an a plus 2, or sorry, a plus 1. Okay, now I move on to my second expression. I only write down the new factors. So we have an a minus 4. Do we already have one listed in our LCM? Yes, we do, so we don't need to write it. We have an a minus 5. Do we have an a minus 5 in our LCM? Not yet, so we better write it. So then we have to add a minus 5 to the mix. Okay? So like I said, this is going to help us when we're adding and subtracting on the next page. So let's go ahead and do that. Okay, so now we're going to add and subtract rational expressions. So we did a little bit of the back work on the first page there. All right, so there are a few steps to follow. Okay, so let's zoom in on our steps and then we will practice some examples. Okay, so step number 1, when we are adding and subtracting, we need to factor all denominators. Completely, okay? Whenever necessary. The next thing we will need to do is we will need to find the LCM of the denominators. Otherwise known as the least common denominator, or LCD. Okay? Step 3, after we find the LCM of the denominators, we are going to get common denominators. And what's going to happen is that LCM of the denominators, that's going to be our common denominator. So we will use that LCM as we figure out the common denominators. The step 4 is we are going to then combine the numerators, either add or subtract, depending on what our operation tells us to do. And then finally, we simplify. Okay? All right, so let's get right to a few examples. All right, starting with example A. We want 5a squared over 6b plus 9 over 5a squared b squared. The first thing we want to do is determine what the least common denominator is, or the LCM of the denominators. Okay? So, what I like to do, and if you need to do a little side note, we have 6b, okay, and we have 5a squared b squared. Okay? So we can go ahead and write down all of the factors of our first denominator, 6b. So we have 6b, and then we can go through and write down our factors of the other denominator. But before we do that, we can go ahead and break up the prime factors, 5a times a, b times b. Okay? So 5, we have a 5 there. I go to my next factor, we've got an a. We don't have an a in our LCM. We don't have another a in our LCM, so we have to write it. I have one b accounted for, but I don't have that second b. So when we clean things up, we should get 30 a squared b squared. And you don't have to do these side notes every single time. You might be able to look right away and say, oh, the first number that 5 and 6 go into evenly is 30, and then I look at my highest degree for each variable. Okay? All right, so the next step is this LCD is our common denominator. Okay, so we need to make our denominators be 30a squared b squared. Okay, so I'm just going to rewrite this expression, leaving a little bit of space because we're going to have to multiply by something, okay? Plus 9 over 5a squared b squared. Okay, so the next step is I need to figure out how do we get 6b to be 30a squared b squared. Well, 6 times what gives us 30? Well, that would be a 5. So I know I have to multiply by 5 over 5. And I need an a squared, so I'll need to multiply it by an a squared. And then I have a b, but I need it to be b squared, so I need to multiply by one of those b's. Okay? Now, what do we have to do to this second ratio to make our denominator, 5a squared b squared, be 30a squared b squared? Well, the only thing we're missing is this 30. We have the a squared and b squared. So 5 times what gives us 30? It's going to be 6. So I multiply numerator and denominator by 6, and now we simplify from here. Okay? So 5a squared times 5a squared b is going to be 25a to the 4th b all over our common denominator, 30a squared b squared. Plus 9 times 6 is going to give us 54 over that common denominator, 30a squared b squared. And now that we have common denominators, we just combine the numerators. So since those aren't necessarily like terms, the best I can get is 25a to the 4th b plus 54 all over that common denominator, 30a squared b squared. Okay? And then the last thing I would do is see if these three terms, 25a to the 4th b plus 54 over 30a squared b squared, have anything in common, and I would simplify from there. But this one is as good as it's going to get. Okay? All right, let's try one more together before I let you loose on example C. Okay? So, remember step number 1, we have to factor all denominators. So in part B here, we've got x plus 10 over 3x minus 15 minus 3x plus 15 over 6x minus 30. So we factor those denominators. I do not try and factor my numerators. So we have x plus 10. In this first denominator, we can pull a 3 out. So we have a 3 times x minus 5. I'm going to leave a little bit of space so that we know what to multiply by. Minus 3x plus 15 over, we can factor a 6 out of this denominator, leaving us with x minus 5. So we do a little side note now. Okay, our LCM. All right. Another thing we can do is look at the numbers, those coefficients, 3 and 6. What's the first number they both go into? It's going to be a 6. And then we can go through the remaining factors. I've got an x minus 5 in my first denominator, so I have to write that down. Now I go through the second denominator. Well, we've already got this 6 accounted for. X minus 5, is that a new factor or a repeat? It's a repeat. I've already got that written down. So our LCM, or the LCD of our denominators, the LCM of our denominators is 6 times x minus 5. So I need all of my denominators to be this. If we take a look at our first expression here, what are we missing in our denominator? Well, I've got the x minus 5. How do I make this 3 a 6? Well, we're going to multiply the numerator by 2 and the denominator by 2. Is there anything we need to do to this fraction here to get a denominator of 6 times x minus 5? No, we've already got that. Okay, so now the next step is we just have to remember to distribute to both of those guys in our numerator. So 2 times x is going to be 2x plus 2 times 10 is 20. Our denominator is that LCD, or LCM of our denominator, 6 times x minus 5 minus 3x plus 15 over our common denominator of 6 times x minus 5. And now we just combine our numerators. Now we have to be careful this time because we are subtracting, okay? So just watch your signs. So we have 2x minus 3x gives us a negative x. Then we have 20 minus 15 is going to give us a plus 5, okay? All over 6 times x plus 5. Now this looks like we're done, but now what we need to do is treat it like a problem from yesterday, where we factor the numerator if we can and see if any factors cancel. So what we should notice is, let's pull out this negative, okay? So if we factor out that negative 1, we will be left with an x minus 5 in the numerator over 6 times, oops, I made a mistake back here. Let's see. This should be an x minus 5. Let's just change that. That should be an x minus 5. Sorry about that. And so we've got this x minus 5 here. And now what do we notice? These x minus 5s cancel, and we're actually left with negative 1 over 6. That's as simplified as we're going to get. So you always have to double check if you can factor that numerator at the end to see if it cancels or any factors cancel. Okay? All right. So from here, I want you to try this last example on your own. Determine the LCD, the least common denominator. Get those common denominators and combine your numerators. So go ahead and try that now. Okay, so you should have gotten this as your final answer, x plus 7 over 5 times x minus 3 times x plus 2. And you should have determined that your LCD was 5 times x minus 3x plus 2. If you have any questions on this, make sure you come to class tomorrow with those. All right, have a great night, guys. Bye.